Welcome to Turn Right Machine Works. My name is Keith, and today we have a project that we've got to get a broken bolt out of. This is one side of a fork assembly for a motorcycle. The customer brought it in just the other day. He also gave us a sample of what broke off. It broke in removing it. The scenario is that the former owner that had it chromed probably ran the bolt in there without chasing the threads that had probably chrome buildup on it, and just ran it on home, and it's probably galled right into there. Then he went ahead and took a pistol drill and very carefully tried to get it on center, which ended up running off. I'll take a picture directly straight in to show you the hole. Now this is 3/8 National Course socket head bolt, and I have a helicoil kit for 3/8 16. Just happen to have one in the cabinet. I've already rotated my head around. Now here's the thing where we have, this is a shock absorber, so this end you can't grab a hold of at all. So then you have all of these odd shapes here, and you really can't get it in a vise, because if you did get it in a vise, holding it here, it'd be so choked up into the vise. What I'm going to do is I'm going to go ahead and look for a piece of material, machine it flat on both sides. It's going to hold this using the two faces on the bore that are exactly 90 degrees to the axle, or the axle bore 90 degrees to the pinch bolt. And then I'm going to clamp that right down, and then I'm going to take and indicate lengthwise on an area here, maybe even scale it so that I'm straight in line enough to go ahead and then dial the hole in, and then come in and hit that with a carbide end mill to try to remove the half a bolt out of there, and then proceed with the helicoil. So let me get set up here and we'll get started on here. Here's a shot of the hole itself. Alright, we find ourselves a tube here that's the right diameter, that all we got to do is face out both ends, and we can put the part up there and run the all thread down with a T-nut and a washer on the top. Alright, that almost cut like it was leaded stock, and it may have been. I see it's been bored, and I can see the tracer mark where the tool bit came out. So, but anyhow, we are parallel now. We can use this to clamp our part down to the mill table. Alright, I found a bolt here in the T-nut that I believe is going to be long enough here for our combination of what we added up here, the thickness, and we have a couple spacers here. Alright, I'm going to put this flat down on the table here, kind of like spread it out, so I know I'm kind of coming up through the center of it, and I want to maintain kind of, as close as you get in the center, you know you're going to be holding with the best strength. Just feeling there's no burrs or anything else on here, and I know there's nothing on here. Alright, hold that so we're pretty well centered there, and we're going to drop. This is a piece of aluminum, and it's pretty well hits that whole surface right there. And then a regular steel mill washer. Gonna push down on it. I'm gonna lightly tension up on here so I can eyeball underneath, make sure that this whole thing is kind of supporting as best as I can on that washer surface. And underneath, looks like this could go a little bit that way. Alright, that looks pretty good. We're gonna cinch this down. Okay, that kind of like lifted it, straightened it. Okay, we can easily still put this side to side. We're going to eyeball this down the center of the mill table, kind of like that. Just we're gonna call that pretty close. We're not done yet. Okay, because I'm going to come up off of this edge with a straight edge, measure over to 2 points on here, but I want to verify that the cylinder here is 2325, 2549, so we can't do that. 2545. Oh, we had it cut out there. Let's see, 271. Okay, we're going to come off of this straight edge here, and we're going to have to come all the way back here to our ram, which is exactly parallel all the way through. And we're going to come up and we're going to measure 2 points of that distance right there with a long straight edge, and we'll push this back and forth until we get a line, and we're going to call that our axis that we're going to go ahead and zero in and attempt to remove our broken bolt there. Alright, this is our 24-inch Starrett rigid scale, and this is just a project engineer scale, but it reads in hundredths. And I use this block here to keep it level, and then tilt this to keep this in line. So it holds it pretty square. I'm reading in here, I got about 3 inches, 230, 240, somewhere around in there, and about 3 inches. Right in the same ballpark there, maybe 220, 230. Alright, I'm happy. I'm going to leave it right there. I'm going to cinch it down. Okay, I brought you around to this other side here. We want to hold an extra support just in case the tool pressure coming on here is not going to want to move this thing around. So we're going to give it another support right here at this point. And this is chrome and everything else. I don't want to involve myself on scratching that up, so I'm going to put that there, and I figure I got a spacer block that's going to fit in here somewhere, so that my resting point there, I got a stud and T-nut here. I believe it'll be high enough. Yep. Alright, get the angle of the dangle here so that this is coming in and catching the top of that ball. The stud will be pulling straight up, and the pressure will be just downward on the screw jack, and that added support will keep it from pivoting back here. Alright, let's do a quick double check on our dimension here. Same thing, 3 inches, 230, 240, somewhere around in there. That's going to be straight enough. And we're rigid enough. And we're holding it in line to the axis we want to go ahead and center up on that bolt hole. Alright, so let's come around the other side and let's start playing around. I got to hunt up a 5/16 carbide end mill. I don't know if I have one, but I'm going to hunt one up, or at least the closest thing that I can get to it, so I can start going in and cutting out the remainder of the bolt there, because it's only a partial bolt, and the first thing we got to do is kind of get rid of that offset hole, put a hole in straight on line, and then pick out or get out whatever remainder is afterwards. Alright, we put in our collet. This used to be a Jacobs chuck holder. This is a Jacobs taper here for a giant chuck. Of course, I don't have any chucks that big, and I already have a drill truck for the K&T. So I turned this into a 3/8 holder, and that's what I'm going to do. Is I'm going to go ahead and put my coaxial indicator on here, and then I'll be able to reach in this hole. So I'm going to roughly bring this over here and get this started up, and then I'm going to bring you around to the other side so you can see where I'm indicating this hole and how we're going to determine to be center on this hole. First thing I do is I put my spindle in neutral, which I usually have it in there. Bring this in a little closer, just so I can eyeball. Alright, then we'll go ahead, we'll bring this in, hold it there. Sometimes you want to throw these coaxials out, but it's got plenty of throw. Okay, we're going to lock up our tables because we're pretty close now. Hit our verticals. Tension up there a little bit. Okay, that's within about 1. I want to go ahead and I want to spin it. Oh, that's pretty good. It doesn't have to be real fast. And I always spray a little bit of lubricant in the hole here for... Alright, now we can bump it in and out. Going a little bit more. Back the other way. So in and out's about 1/1000th or 2. There we go. There we go. Alright, I'm gonna call that 0. We're bouncing within a 0.5 thousandth. Alright, we have a split line here, and the bolt actually is broken about 200 thousandths up inside there, I believe. No, about 100 thousandths. I know it's above this split line because I can't pass my scale through the split line because the bolt, part of the bolt is still there, the part that's offset from where he drilled. So what I want to do is I want to come in with a 3/8 cutter. I think is my first bet. I'm going to come in 3/8, exactly 1 inch deep here. So actually, yeah, I'm going to go 1 inch 100 thousandths from the face. Then I know that I'll have a starting point where the threads actually start in this piece here. I'm going to eyeball this square with the end here. About another 20. That looks pretty good right there. Alright, let's set 0 on this dial. And then I'm going to take a Sharpie because I usually measure out here on my table so I can eyeball it. And I'm just going to mark 1/100 from the end here. We better put that in the right direction. Alright. Okay, and I'm just hand cranking it. Okay, we're about 300 from there. We're starting to touch something in there. Heard a little crunchy crunch. I see a little bit of chips coming out of there now. Okay, I'm gonna blow the chips clear. Half an inch from there. I'm going to back it out just so I can verify where I'm at. I believe I'm right on to I'm probably about 50,000 from being where I want, but I want to verify that myself. Alright, mark my dial over here, 200. Might as well give myself plenty of room here. And just verify we were half an inch, and that's 1/550, so we were about 1 inch 50 thousandths, and I figured that we had about 50 thousandths to go, so that verifies that. Doing the thumbnail depth gauge here. It shows that it's pretty close there. Let's see. I still can't pass this through, so. Okay, let's mirror it. Looks pretty good. The hole is going through the whole part. I mean, it's not skirted out to the outside edge, but he wallowed out more of this material here than he did wallowing out center of the bolt itself. And I'll have to take a picture of that for you. All right, when I go like this, you can barely see the scale. I can't quite get it to go over the front of it, but I can see that I'm touching, and it could use every bit of the 50 thousandths that we need to go here. So let's jump right in here and get back on it. Okay, we're coming up on the 200 here. Okay, there's 200 there. And I figured another 50 thousandths. Play it safe. All right, that looks good. Okay, I saw some dirt squirting out of the split line. Look at that. Now we can bypass that. Take a look in here, see if this looks any better. It actually looks like he's really close to being on center here. Let me give you a shot of this. Hey, for a pistol drill, this guy was right on. Just a little bit out of the mouth, he had to angle it because he knew it was probably running a little bit off. We might actually be able to save this, but well, let's not count our chickens before they hatch, right? right, next step. Let's come in with a 5/16 drill bit or end mill and see if we can't make sure that we're straight on, dead center in there. Okay, this is where I don't have a long reach 5/16 end mill. This is like 330 here, 340. That one there would be long enough to get down in there. This one here is 5/16. What I'm going to end up doing, I'm going to baby this, but I'm going to be putting a set screw in here in between the flutes back behind here. So I'm actually extending this out farther than it should be extended. And I'm doing it on the same side that the relief is cut in here. Alright, so we're locking this in. Yeah, we are. One of these hours. Alright. So we're going to go ahead and we're going to take the set screw and we're going to lock it down in on that relief right here. We're going to be leaving this thing sticking out. We had one area here that we knew it was. Alright, we're going to be babying this because we don't want to shatter it. About 1.5 inches to going in there, which will give us about 7/16 of an inch down in there. This should hopefully give us a little bit more right down the center. Once we start going down the center, then I do have a 5/16 carbide drill. So all I need to do is at least get a start, and then this thing should follow the hole that we have. And then hopefully we can peel out the rest of that bolt that's in there. And we're going to reset our 0 here so we know where we're at to our dial. Okay, we're getting close to it. Okay, I'm hearing it cut. It is a hardened bolt like grade 8. Most Allen Bracos are. Okay. I just want to check and make sure we're not just melting down a high-speed steel end mill. And we are working the edges a little bit there. So let's take a look in here. It was just off just a tiny bit, but not bad. I'm taking another last look to see if I have any 5/16 end mill or end mills at all. Alright, I didn't find the 5/16 end mill, but I do have a 9/64. It's actually like 294 on the diameter, which is just barely over what was drilled and just under what I want to take it to as far as my drill. I'm going to run it in a drill truck. This is typically a no-no in my book, but I have no choice. It's rigid, it's sound. I'm going to be babying it. We're not really coming in, we're not boring, we're not asking this thing to cut a precision hole. We're just asking it to whittle away on an off-sided hole, which it's probably due for another picture here, I guess, for it's what it's looking like, and you can still see how close he was on drilling the hole. All right, here we go. All right, we're flush with the end. Reset our dial here. And this is because we're still trying to attempt to grab out the original material. I'm not trying to do a left hand type of thing or anything else on here, because I have a feeling, just like the guy said, it's galled in there. You're not going to get it out with an easy out or anything else. Okay, I'm at the thread contact now. Oh yeah, she feels like she's cutting really easy compared to that high speed end mill. She's not vibrating around. She's throwing out a nice easy chip. She's following the hole pretty good. I'm going to get everything that I can out of this here. Okay, that's about everything without putting a scoring mark on that top side there. Got a good pile of chips out of there. There we go. We're getting in focus there now. Okay, you can see the skirt all the way around on that outside part of the hole. And his bottom hole, as it gets closer to the bottom, it's closer and truer to the center of the stud. So we still have enough material here. And I think I'm ready to go in with a 5/16 drill. It'll be down through the center enough, and it'll catch that bottom. So I think I'm going to switch over to a drill now. I'm just coming in by hand, and I'm going to put my hand on here because I'm going to feel the cut action on it when I get close to it, or when I touch off on it. Okay, right there I'm starting to touch it. Really hoping this drill bit cuts pretty good, because I hand sharpened this carbide tip on here. I'm getting the chip out of there, and I'm not really having to force it in, so it must be cutting pretty good here. Alright, I think I've gone all the way through it. I'm going to put a mark here just so I'm almost right at that mark. Let's see. Okay. Okay, we're all the way through, and we're centered with that. Alright, I got 3/8 starting tap here, and I've just been fiddling with it, working here and thinking I might get something to catch or pull out the threads there, and it actually seems like I get about 3 or 4 threads right now. Just working it and clearing it out. I can always go in here and put a helicoil, but I'm just trying to, if I can chip out the remainder or even get something started. It's kind of hard to tell because I think hard to tell whether it's actually starting new threads or knocking the other ones out. I'm actually starting to pull a thread out of there, so I'm going to reach in with my pick as soon as I find it. Here it is. I think I got a piece broken off in there. Alright, there's one. I'm getting a couple chunks out of it. It may be better just to go ahead and drill it out for a helicoil now that we have a nice clean hole here. Before I stick or break a tap in here and cause more of a problem. And that's what it's doing. It's just it's working its way on down in there, but it's not going to be pretty. It looks like it was galled. Okay, we've got the tap size for the helicoil. We have helicoil we're going to put in there. We have a dummy bolt here, and we're going to probably stitch around, see if we can got another one here, because this only gives us about a 1/2 inch down into this lower section here for thread engagement, and I like to have something maybe about 3/8 or a 1/2 inch in length to be receiving female threads down in there for the helicoil to comfortably set in the area I want it to. So let's go ahead and we're gonna drill down into here. I'm just kind of gonna do this by eye here, actually by feel, because we know that we're gonna come down all the way to the bottom down in here. I'm gonna slow this down just a little bit. I just hate to punish the drills that are made for my helicoil kits. And this will go all the way through the upper half before we get, now we're just down to the threaded area now. And I can hear it pop a thread once in a while. I can see some of them pop out down here. Okay, I'm down at the bottom for full depth. There's a lot of like corrosion powder or something in there. And it's a good looking hole now. Alright, there's our tap follower. We're going to go ahead and back this up and give us some room. So my straight T-handle is too long handled up for this, so we're going to come in here using this T-handle, which should be fine. I'll load it by hand here. Tough metal, whatever it is, or maybe I'm just used to tapping helicoils in aluminum. I'm going to pull this out and hold the threads along to the outside and take a look at if I got it deep enough. The length of depth that I have is all the way up to the thread height on the tap. Now, I could go a little bit more. I go about a 1/4 inch more. I'll blow it out and clear it out and go back in. That'll be deep enough. You know, the more we work that hole, the better it looks. Okay, I'm going to put this insert in, and I kind of want to have a minimum area where I'm going to be a depth I want to put this to, so I don't want to overshoot it, and I don't want it too high. I want it to be about a thread down below this surface. So I'm going to say that little blue line flush with that outside will put this helicoil where I want, and kind of like in here to right there. That's the range I want it to be in. About there. Okay, that's where my mark is. Feels good in there. I'm gonna back this out. I want to make sure the scale passes through here. It does. The coil looks good down in there. Three-eighths socket head screws into it. I just wanted to put, it doesn't hurt to have a little bit about a thread down below this surface of the split line, so that's what I went for just now. Alright, now we can go ahead and we can knock that out, and we just need a piece of 5/16 rod. One that came with the kit is missing. So what we do is we just go ahead and we get a transfer punch. Slightly smaller than 5/16, and then we can break the little tang with that. There we go. And there comes the tang right there. All right, let's go ahead and remove our jig here, and then we can get a good look down into the bore of that. Ball bearing idea worked out again. Pull off our screw jack. Nice. We'll lay a good clean rag up here. Okay, a good rag. And let's get you a sight down it. Okay, this is about as good as you're going to get with the regular video camera here. but I'll go ahead and I'll get in a better zoom there with my my Note 4. Okay, you can see the helicoil starting thread and the following threads behind there. You can see where the wallered out area is, how far out he originally was. Just angling it in, and should be able to see it. But you can tell by this here that the center line and the center of the hole is back to normal. There is a little bit of loss of where the head of the Allen's going to rest. You could put a washer there, but then the bolt would protrude past the bottom of the shock mount itself. He may be okay with that. We'll talk to the customer when he comes in to pick this up about that. All right, we're satisfied with our fix here, and this was the ultimate decision to go ahead and go with the helicoil and create a thread that he can put a bolt back in there and actually clamp back onto the axle, and keep the axle in position. Sometimes when people come in and they got a half eaten away hole or something like that, every time it's iffy whether you can save it or not, or the amount of work it's going to take to come into it, or is it even worth it. So we went ahead and we tried to get it out as a 3/8 national course bolt, which was in there, and of course that would be the ultimate, to go ahead and just bring it back out, clean it out, and get it back usable again with the same bolt and everything else. But we had to go in there and we finessed enough, and the setup gave us a true enough alignment to come in and get a hole in relationship to the original machine casting and everything else of this. We're happy, and the customer now can put his bike together and probably save him a few bucks. I don't know what these go for, and whether he'd have to have a new one chromed up or whatever's going on. But it's also something to think about. If you got a chromed item or whatever, when it comes back and you're fitting it up on your hot rod, your hobby, or even a job, if it is, all your threaded holes, you want to check and chase them, make sure that everything's fitting in there. That's a good practice. Even if something comes back from sandblasting, you should be running through some old chaser taps just to knock out the sand and grit and everything else, because it just takes a little tiny bit to gall a bolt, and that's more or less, I believe, that's what happened here. And there was all kinds of white powder that came out of this, so I don't know if it was road salt or whatever got up in there. I see just a little bit of blems and like the chrome, like some of the areas here have seen a little bit of rust buildup or whatever. It's polished now and kind of waxed or whatever for its condition right now. So who knows what was actually in there that kind of came out like white powder. Anyhow, I'm going to go ahead and set this off to the side until the next job. Get her done.